Hi, I welcome you protocols for EV application session. In this session, we will discuss what is the electric vehicle and how we can identify the subsystems, what is the basic communication systems and its parameters and types of communication systems, protocol and its types, and how to identify the vehicle networking and how we can implement in the hardware systems. So the theoretical topic we will discuss, and finally how to select a new protocol for a new features and protocols for EV charging industry. If you take electric vehicles, see the electric vehicle will give you the very low cost and carbon free environmental benefits. So on this point, electric vehicle is going to lead the entire transportation industry, and each and every vehicle has its own subsystems with electronic control unit. In this electric vehicle, there are lot of subdivisions are there. So each and every subdivision is called as a subsystems, and each and every subsystem needs to be interfaced with the main model. So in the electric vehicle, we can call it as a main unit, as a cluster, see, or else diagnostic systems. And for the driver informations, the main diagnostic information cluster will have all the information about the vehicle. And if you take, suppose if you take a battery management system, so the BMS model, entire BMS model will be available on the cluster. So the from the driver point of view, if driver needs to know about the battery informations, what is the battery balance charge, and then distance, how long we can cover with the available energy, and what is the temperature rises. So everything the driver can get it. So here the information is a one model, that is a cluster model is a one model, and the battery management system is another model. So now we have to transfer the data, like either basic data or else a video type of data can be transferred with the help of some communication medium. So for that one, we should know what is the communications, what is the basic parameters of the communications. So if you take a type of subsystem, so the typical subsystems are nothing but the chassis systems, airbag system, powertrain module, and then body and comfort electronics, multimedia and infotainments, and X by Y wire model, like mechanical power transmissions, and then wireless and then telematic systems, and then diagnosis system. These are all the individual subsystems. Each and every system has its own protocols and its own electronic control systems. So here the analog signal, like suppose if it is a chassis system, so in this chassis systems, some sensors will be used to monitor the data, and the analog sensor will connect with any one microcontroller. So that microcontroller will send the data to the master one. So if you take the chassis system, this is a small subsystem compared to the master one. And for the communication point of view, see, actually here the sender and then receiver. So between this sender and the receiver, the message is going to transfer, and the message will be encrypted in the sender end, and it will be decrypted with the receiving end. And again the transmission system will cancel the noises which is generated during the transmission as well as the receiving section. Here the entire transmission system will be formed with the help of a microcontroller. So in between the microcontroller, the protocols has been implemented. So let us check one by one. And what is the parameters for the communications? So the first one is that the transmission system should have a fault tolerance and determination, and bandwidth, it should have a high bandwidth and flexibility. See, actually in the electric vehicle, so wherever the temperature rise and the vibration rise will be there. So while the data is transferred, the flexibility should be there, so that the data loss will not be available. And finally the security. See, because actually wherever you want to transfer any message, there obviously the security system is required. So now if you take a subsystem and then this parameter, some subsystem needs a security model, some subsystem does not require a security model. See here in this airbag system, suppose if you take airbag system, so this airbag system does not require the security model. So in that case we can choose very low cost as well as that flexible, highly flexible communication systems. And what is the protocol? So the protocol is nothing but it's agreement about how to do something. See here in this electric vehicle, so there are a lot of subsystems are there, right? So if you take a dashboard and then a battery management system, so between these two models, we should send the data with the help of microcontroller. See, generally in all the subsystem it has its own microcontroller because it's a kind of electronic control unit. And in the dashboard also will have some electronic microcontroller. Similarly, the BMS model also will have some microcontroller to maintain its local data. And similarly, suppose if you want to transfer any message from BMS model to dashboard, so like a cluster. So in that case, my dashboard will send a request message to the BMS model. Whenever the BMS model receives a request message, so during that point only the data will be transferred to the dashboard. Similarly, we can generate a protocols. See, actually, if you want to transfer any message, there will be a set of agreement. Like first, you should send a request message. Then I will send you the message. And after that, once if you receive the message, you have to send an acknowledgement. So, like that, this is the agreement to implement a data transfer. So this is called protocols, generalized protocol. So in the automotive electronics, there are a lot of protocols are there. So we can classify three types. One is called data link protocols and application protocols, and then generalized protocols. In the data link protocol, see again here, if you want to transfer the message, generally we can call it as a three type of message. One is called the low bitrate message, and then medium bitrate message, and then high bitrate message. We can classify the bitrate, low bitrate message under that integer data types. Suppose if you want to transfer the file as a video file, so in that case you should have a high-end applications. High-end microcontroller is required to implement the particular transmission message. So like that we can classify into three types. And see, for example, if you take a UART protocol, so in this UART protocol, you can transfer all the kind of data. Where comparatively, if you take a CAN protocol, so you see here also you can send the data, integer data, that is called low bitrate data. And similarly, if you want to have a high-end protocol, so that is a high-end file message. So in that case, you should have a Ethernet protocol. So via the Ethernet protocol, we can transfer the like a video file or audio file with the high speed range. So in that case, UART cannot be implemented. So UART will be less, speed will be less than the Ethernet protocol. So like that, we can classify into three different types. So let us check one by one. So in the communication types, so wired technology as well as that wireless technology. So in the wired technology, if you take automotive protocols, the first one is that local interconnect network. So this is invented by 1998 and by the consortium of automotive industry. In the Europe, all the automotive industry formed as a consortium to generate to identify this network. Actually, all the vehicle manufacturer will form a body. That body will fund a research laboratory. So that research laboratory has invented this protocol to give the perfect medium to transfer the data from one end to another end within the vehicle itself. And the standard is open source network, so any manufacturer can download the LIN protocol, then they can deploy into their controllers. And so far in the 2001 LIN 1.1 and then 2003 LIN 2.0. So this is the update in this particular network, and it's a very inexpensive network, speed up to 2 kbps. And this is one wire system and generally used in the body and as well as the comfort subsystem. For further, we can integrate LIN along with the CAN gateway. So let us check one by one. So keep engaged with the entire class. In the CAN network, that is a control area network. See here, this is Bosch invented this protocol in 1980, and also it has a two-wire system. So this CAN is a two-wire system, and its speed is 150 kbps. And this is generally it's a broadcast type of protocol. See, if the master can spread the message for the entire subsystem, so this is called a broadcast type of protocol. And similarly, the byte flight, so this is invented by 1996 by BMW, and its maximum speed is up to 10 Mbps. And next one, the safe by wire technology. So this is also commonly used for master to slave network, and mainly used for the airbag control systems. And Motorola interconnect, so this is similar to the LIN in the sense that it is a simple low cost master slave type of network. And smart sensors in comfort electronics such as seats, mirrors, and windows lifts. And however, LIN is close to being a world standard in automotive systems today. And similarly, next protocol is called a distributed system protocol. So this is dedicated for the airbag applications. And next one is media oriented systems transport. In 1997, BMW, Audi, and Daimler Chrysler, they have founded this one. So mainly for the video displays, and then GPS navigation, active speakers, and then digital radios. So for these applications, this protocol has been used. And domestic digital bus, that is called a D2B. It's a ring and star optic network providing up to 20 Mbps communications. It's mainly used in the Mercedes-Benz models. And next one is mobile multimedia link. So Delphi Automotive System invented this one. So mainly again this is also common for the master slave optic networks. Maximum speed is up to 100 Mbps. So again the CAN is modified, that is the TT CAN. It is again support of the coexisting event and time triggered traffic together with the fact that is standardized by ISO. And the flux relay, so it is invented by BMW Daimler in 1998. Speed is up to 10 Mbps. In the wireless technology, Bluetooth, Zigbee, Wi-Fi, and then ultra wideband IEEE protocol is used. Actually, these wireless technologies again here it's a common technologies for transfer low bitrate data and then hybrid medium and as well as the high bitrate messages. So here with these wireless technologies, we can transfer any size of messages like video, audio, and then basic integer data. And if you take a vehicle, if you take any electric vehicle or any commercial vehicle, see actually each and every model has its own subsystem. See here in this subsystem, suppose if you take a instrument cluster and then hybrid vehicle charging stations or ABS model, so this model will work under that CAN protocol. Similarly, we can integrate this, that is ABS model with the light door lock system. See, actually, this door lock system has interfaced with the LIN protocol. See, actually, all the protocol can be interconnected with the help of gateway or else protocol converter. If we take this model like a door lock and then instrument cluster, if you take this one, so actually in the door lock will have a sensor, that is that sensor will use to identify whether the door is open or not. So the information needs to be transferred to this cluster model. So again here this in the cluster one TFT display will be there. So that display will have a microcontroller or a DSP model, that is a digital signal processor will have it. So this model will sense, will display the door's status in the cluster model. So for that one, so here the two type of protocol has been used. One is that CAN protocol and another one is that LIN protocol. See here in between these two one, see here if you take a CAN network as well as that LIN network, so this two network can be implemented with the gateway or else converter. So this converter will carry the message, the exact message from the LIN bus to CAN bus. In the hardware systems, see here if you go to our website, so there you can identify just visit pantechsolutions.net or else just go to Google See here you can identify some protocols, examples. So just visit CAN example Pantech solutions. See here Arduino project image processing CAN example and protocol. Yes, so interface CAN with the microcontroller. So you see here, if you want to know this one, so first you should know what is a microcontroller, so what is its basic architectures, and how to write application code with this particular microcontroller. So this is LPC214, it is ARM processor. So here, with this page you can identify the basic initialization code, how to integrate, how to send a message via the CAN protocol from one end to another end. So generally we need two microcontroller. So this two microcontroller, so here one microcontroller will have a CAN model. So here you can send a message from the microcontroller to CAN model. So in the receiving end, first the CAN model will receive a message, and from the CAN model the microcontroller will verify whether the received message are very correct or not. So based on that, we can implement a perfect CAN protocol in the network systems. So how to select a new protocol for a new features? So first you should identify what is the maximum payload size, like that is a message size, and a network bandwidth. So how long, what is the type of a message you are going to use it? This is the second. And the next one, maximum bus length supported, and architecture, whether is it master or slave configuration types, and transfer mode, that is that in which duplex we are going to transfer, and synchronous or else asynchronous type. And then fault tolerance, what is the maximum fault tolerance which you are going to implement in the new protocol. And next one, that is the suitability for the safety critical features, and easy of addition or removal into or from the vehicle network design. So based on this behaviors, you can identify a new protocol, and for the any new features. Suppose if you are going to use vehicle tire measurement systems for a common for a standardized support systems. So in that case, you should follow the entire behaviors to identify a new protocol. EV charging industry, standards and protocols which delivers the flexibility that is needed for the entire electric vehicle market, and it will be a key enabler of future EV charging infrastructure developments. And each and every charging station equipment manufacturer will needs to be implemented all the protocols to handshake with the electric vehicle as well as the grid. EV charging standards as of worldwide in the Europe type single phase AC, so up to 3.7 kilowatt. Similarly, single phase or three phase AC up to 3.7 to 22 kilowatt, and maximum current is up to 32 ampere. And similarly for the three phase or else multi phase systems, so above more than 22 kilowatt, and amps rating is above 32 kilowatt, so 32 ampere. And DC fast charger again above 22 kilowatt, and then ampere rating above 32 to maximum 400 ampere will be the maximum ampere. And for a USA standard, again the level 1 level 2 is up to 32 ampere, and the DC fast charger up to 400 amps with for 240 kilowatt. So the voltage range will be about till 700 voltage DC bus voltage. And as for the Indian standards, see here there are two different type of charger type. One is the fast and then slow or moderate. In the fast charger or else a DC charger, that is DC charger like type 2 AC minimum, that is called 57 ampere is the maximum ampere. The voltage range is 380 to 415. So this standards is as of 2020 standards. So for 4-wheeler as well as the 2-wheeler. Similarly, for the Bharat standards, EV charging station standards, DC001, that is up to 15 kilowatt and up to 10 kilowatt. So current rating will be about voltage is 48 voltage, and then ampere is 300 ampere. and similarly for the 72 voltage with the 200 ampere. So this is some typical charging ratings, charging station ratings. And these protocols only for the theoretical part. Again, for the hardware implementations, you have to first learn the microcontrollers and sensor integrations. So once if you know these two things, then you can implement with hardware physical parameters as well as that software application code. So if you finish this, if you follow the two procedures, then you can implement any type of protocol for the any networking applications. And thank you. If you have any questions, you please comment in the comment box.